Good morning. Welcome to the next session of software engineering. Today's topic is perspective models. Now, when you hear the word perspective models, you're going to identify that perspective models, it is basically what is the point of view of a particular person or a particular organization, what they think or what is the methodology they follow. So in here, in software engineering, whenever you're developing a particular model, each and every organization is going to have their own set of activities that they are going to follow to develop a particular software. Now in here, you might be wondering why the name is chosen as perspective models. Now in here, the perspective models in here, the name is chosen because it is going to tell you what are the different activities that you're going to follow and what are the different actions that are going to be followed in here. Now in actions, what are the things that are going to come? The first thing that in actions you're going to study is what are the different work tasks that are going to be used to develop a particular software. Task can mean what is the steps that you're going to follow. That is work tasks. Then the next one is what is the work product that is going to be developed by the result of these tasks that you're going to follow. Then the third and the most important one is quality assurance. Now, whenever you're developing a particular software, there is a necessity that the quality of the software should be very well. If suppose the quality is not up to the mark, then there is no use of developing the particular software, because then it is not going to hold its place in the market. No one is going to purchase it. No one is going to download the particular software. So the first thing that we've studied is perspective. The word perspective is used because it is going to tell you what are the different activities that are going to be followed, what are the different actions. And the third one is it is also going to tell you, or it is going to tell you how you can manage the change. Now in here, change means if suppose a set of features were defined at the inception phase, at the beginning of the phase. Now if you want to change some specific feature, you want to remove that and add another one, you can do that. That is perspective models. Now in here, let's go to the next slide. That is what are the different types of perspective models. There are three different types of perspective models in here. The first one is called as the waterfall model. The next is the incremental process model. And the third one is the RAD model, where RAD stands for rapid access development. Now in this waterfall model, it is also called as the classic lifecycle model. The classic lifecycle model is the next name that was given to waterfall model. Now this waterfall model, you can say that this was the first model that was developed. The first model that was developed within the software development lifecycle. That is what the first model that was used to develop a particular software was the waterfall model. Now in this waterfall model, the name waterfall means it is going to follow an approach that the water is going to fall from top and then it is going to reach the bottom. That is, it follows a sequential approach. Now, coming to the diagram for the waterfall model. Now in here, in this waterfall model, there are 5 steps. Now in this 5 steps, the first phase is communication phase. Now in this communication phase, you can see that there is project initiation and requirement gathering. Now communication, it means first what you're going to do is there are 2 persons whenever a software is being developed. There is an end user. That is an end user in here is going to mean that there is going to be a customer, an end user. And then there is going to be a developer that is going to develop the particular software. So in here, there is going to be heavy communication with this end user. Now in here, the term end user is used for a customer. So this customer, you're going to communicate heavily with this customer so that you can gather all the requirements. All the requirements are gathered from the customer at the communication phase. All requirements are gathered in here while communicating. The next phase is called as the planning phase. Now in this planning phase, what are the things that are going to be planned is you're going to identify what are the different tasks that you're going to follow. You're also going to identify what is the risk. Now in here, you might be wondering what are risks. Risk in here means that if suppose adding one particular feature is going to affect another feature within the software, or it might create a bug, that risks are going to be identified within the beginning of this phase. Now in here, one thing is that when communication is over, then and only you're going to go to the planning phase. when planning is going on, you cannot go to any other phase. Now, because I told you this is a sequential approach. When one is done, or the waterfall model, it starts from the beginning and then it goes to the second step. Then it is going to go to the last step. So in here, you're going to identify the set of tasks that are going to be followed, the risks that might occur. You're going to identify those risks, and you're also going to identify what are the resources that are going to be used. Resources means what are the different technology, how many people are required, how many systems are required, how many coding tech people are required. That is going to be identified. And the most important thing, you are going to create a plan. A schedule is going to be made in here. A schedule is made within the planning phase. The next phase is modeling. Within the modeling phase, this modeling phase encompasses of two things, analysis and design. Now in here, within this modeling, analysis and design phase, in here you're going to create a model. Now this model that you're creating, this will be called as prototype. This model is going to be called as prototype. That you're not going to tell model, you're going to tell the name as prototype. Now why we are developing this prototype? Because the end user and the developer both can identify what is the requirement of the software. That is, when the end user is going to see the model, he's going to identify, these were the set of requirements, they are there, checklist. And this model is also going to help to design all of these features. So this model is being created, and based on this model, the end user can give feedback to the customer, to the developers. Then going on to the next phase, construction. Now by the name construction means you're going to make the code, and as you're coding, when the coding is done, you're going to test. Or if suppose you're doing it in multiple parts, one code is being generated, it will be tested. You're going to test for any types of bugs or errors. They are going to be identified. Then when the construction phase is finished, it is going to go to the deployment phase. Now in this deployment phase, deployment means delivery of the particular product to the end user. Now in here, support in here means that if suppose there is any troubleshooting required for the software, the developer is going to give support to the end user. And then based upon this evaluation of the software, the end user is going to work on the software, and then he's going to give you feedback. That is how the software is working. If any changes are there, that changes are told to the end user that they're not working properly. So based on that, support will be provided to the end user. So these are the 5 phases, and this 5 phases, if suppose you are in deployment phase or in construction phase, you want to make any change within the software, this cannot happen in here. It follows a linear approach, and no changes can be made while the software is under development. The next one is, we have considered what are the different phases of the particular software. Now we need to identify what is the real-time use of this particular software. Now in here, real-time use means where are you actually going to use this particular software, that is going to be identified. Now in here, if suppose we want to develop a particular software in where you're going to consider a system where time and money are secondary. That is, in here, the life of a particular person is the first priority. You can consider an example as a life support machine. Now within this life support machine, you're not going to find out first what is the cost, what is the time. Your first and foremost priority is the life of the customer. The particular software should not fail. In this type of process, in this type of areas, the waterfall model is being used. And another example is aircraft programs. When an aircraft is going to be developed, you're going to check for the engines, the white box, the black box, the seating, the wings, the wheels, everything should be aligned perfectly. Again, in here, you can see that the time and money is not important, but human life is important. Because in here, there are many countries that are going to give a lifetime imprisonment for these type of errors. Any fatalities are going to give you a imprisonment. Another one is it is used in military and defense purpose. For all these types of applications, a strict standard process is to be followed. That is why you go for the waterfall model approach. Now coming on to the advantages. Now in here, as you studied that there are 5 phases of this particular model. What were the 5 phases? You've got the first phase was communication. The first phase was communication. Planning. Modeling. Construction. And deployment. Now these 5 phases, these should be followed in this particular manner only. Like these 5 phases, whenever you're writing this, these are not going to be jumbled. First, communication is only going to come, then planning is going to come, modeling, construction, and deployment. Now, what happens in here that many real-time projects, they do not follow a sequential approach. Many people nowadays, when a set of requirements are identified, they want a few more requirements, or a few set of requirements they want to remove completely. They want to change the complete set of requirements. So many real-time projects, they do not follow this sequential approach. That is one of the disadvantages of the particular project. Then the next one is it is very difficult to go back to any stage after it is finished. As I told you that it follows a sequential approach. That is when communication is done, then only planning is done. If you again want to go to communication, it is not going to happen. If suppose it is very necessary, then the entire project has to be removed and then you're going to start from the beginning. It is going to increase the cost of your project. The third one is a working version of the program will not be available until late in the project. That is, until the entire software is being developed, you cannot make use of any of the feature of the software. Then advantages, simple and easy to understand. The CPMCD, the 5 phases, they are very simple and easy to understand. The second point is phases do not overlap. That is, in here when communication is going on, planning is not going to be carried out. While planning is going on, you're not going to go for modeling. When one is completed, then and only you go to the next phase. Then the last point is it works well for small projects. This particular waterfall approach, it is used for small projects. For very big projects, these are not used. The next model is the incremental process model, the second model. Now in this incremental process model, it is going to use the same approach as the waterfall model, and it is going to apply it in an iterative fashion. Iterative means all communication, planning, modeling, construction, and deployment, they are going to be followed at once, and then again you're going to follow this approach. Now in here, this is a linear as well as parallel flow. Whereas within the previous technique, waterfall, in their parallel flow was not there. Now in here, coming to the diagram, you've got a graph where on the x-axis you've got the project calendar time, that is as the number of days are progressing, and on the y-axis you've got software functionalities and features. Now in here, each and every color is labeled as each one of the feature of the waterfall model: communication, planning, modeling, construction, and deployment. Now in here, within the first increment, what you're going to do, you're going to take one particular feature, the basic set of feature, and you're going to work on that particular feature. Now this basic set of feature is basically called as your core product. Core product means your basic version of the particular software. That is the base. That is going to be your first increment. Then based upon this first increment, you're going to again consider second set of features, and then you're going to again go for communication, planning, modeling, construction, and deployment. Then this is going to be released. Now in here, you can see the difference between waterfall model and incremental model is at the end of each increment, you have got one increment. That is, you can use this particular software with one per set of feature. Whereas again, then in the second increment, you can use another feature. Then these are going to go on until the nth feature, until the entire software is being developed. Now let's take an example for better understanding of this particular. Now we are going to take an example of WhatsApp. Now this particular WhatsApp messenger that was initiated first when it was launched, this provided support for only iPhone users to share photos and messages across different persons. Then it got an update for Android. That is, Android phones could also use this WhatsApp feature. Then within 2010, it got a service for sharing the location. Location sharing was enabled in 2010. Then in 2013, you've got the service for voice messages. You were able to send voice messages. Then you've got the feature for double ticks, that are your read receipts. If anyone has received your message and then whether he has opened the message and read it or not. Then you had the WhatsApp web support. Web support was enabled. Then you've got video calling. Now after video call, you've got this conference call option within that. Then you've got the end-to-end encryption. End-to-end encryption was enabled. Then you got multiple set of stickers, GIFs that you could use. So in here, you can see that when WhatsApp Messenger was initiated, first it was there to send photos across and messages across different set of users. Then it kept on adding different set of features based upon time and requirement. So in here, first increment was sharing messages on iPhones, then location, then voice messages, another increment, blue ticks, another, web, WhatsApp web, another increment, video call conference, another increment, encryption, another increment. Then you've also got the feature for deleting messages. So these are set of increments in which you're going to develop a particular software. Now, if suppose we take another example of this Uber service. Now, within this Uber service, what happened? Within this Uber service, first you had the cars option. Then by cars, you got the Uber X. Then you got the Uber pool in the next increment. Then you got Uber auto services enabled. Then you got the Uber scooter service enabled. Then you got the Uber Eats service enabled. So these are the different increments in which softwares are developed. I hope this gives a better understanding of what is incremental process model. The next phase is when are you going to use this incremental process model technique? Now, this incremental process model technique, it is used when you are short in staff. When you've got less staff, so you're going to go for this incremental model technique. When you got less staff to work on the particular software, you go for incremental technique. And the another one is when suppose a specific deadline is approaching and you want to complete the software within the specific time frame. That is, suppose by the end of the week you have to complete the software. So what do? You hire a set of people that are going to, first set of people are going to work on the first increment. The other set of people might work on the second increment. Then the third set of people might work on the third increment. Then at the end, all the three can be combined. So there are two things where you're going to use the incremental process model. First, you're falling short of staff, and the second one is if there's a deadline that need to be reached, so you're going to follow this particular approach. Then the advantages of this particular technique is that now in here, the first one is that produces business value early in the development life cycle. That is, you can see, like within the first increment being developed, you can see how many people are installing WhatsApp or how many people are actually using the Uber app. You can see people that are using it. You produce business by that. The second one is it is more flexible. That is, if suppose any changes want to be made at the later phases also, those changes can be made within this particular model. Then the next one is it can accommodate some change requests between increment. That is, if suppose one increment is being developed and you want some changes within the previous increment, then you might get an update that is going to enhance that set of features. Every time you get updates for security patches, you get updates on different set of features. So that are changes can be made by using this particular model. Then coming on to disadvantage, it requires heavy documentation. Now in here, heavy documentation is required because in here you've got different set of increments. So for each and every requirement, you have to write detailed set of features for what are the features required, what were the tasks that were carried out, what were the work products that were produced. That is why it requires heavy documentation. Then the next one is it requires more customer involvement than the linear approach. Now in here, customer involvement in here is necessary because in here, whenever you're developing an increment, it is delivered to the customer. Now, when you're going to deliver it to the customer is going to send feedbacks based upon the usage. So, but this is one of the disadvantages. If you're unable to get reviews from the customer, that is a major drawback. This is the end of the incremental process model. The previous model that we studied was the incremental process model. Now the next model is the RAD model, the rapid access development model. Now in here, rapid access development, this is a type of incremental model. The previous model that we have studied, it is the same type of model in here, the incremental process model. Now in here, the name rapid in here, it means that this particular application is going to be developed very soon. Now in here, very soon, I mean in here, like you've got the time span of 60 to 90 days. It is not going to take more than this amount of time. Now, how are you going to complete a particular application within this small amount of time? Now, this is possible because this RAD model, it uses the component-based construction approach. Now, what is a component-based construction approach is? Suppose you are designing a particular software. Now, if you are able to break down the software into small components, it might be made up of 3 different components. If you're able to break down this particular application into 3 different components, that is like 1, 2, and 3. So in here, what you're going to do is that this one particular component might be developed by first team. The second component might be developed by second team, and third component can be developed by third team. So all three of these teams are going to work in parallel. They're going to work in parallel as if they're going to consider all of these 3 different modules as mini projects, and they are going to work upon these. Now in here, these 3 different objects these 3 different components are going to be developed simultaneously. At the end, what you're going to do is you're going to assemble all of these within a particular software. The entire software, when one is completed, you're going to come in and install one. Then second will be integrated, third will be integrated. Then you're going to perform the testing and your software is complete. This is your rapid access development model. Now this RAD model, it was developed by the IBM company. Now this is the representation of the RAD model. Now in here you can see that this RAD model, this follows the same approach of the generic process framework model. Now in here, this generic process framework model, it has got this 5 phases, or you can say the waterfall phases: communication, planning, modeling, construction, and deployment. These are the 5 phases that are going to be used within the RAD model also. Now, as in the communication phase, what happens within the communication phase? The first thing is that within communication, you're going to gather all the requirements from the end user. You're going to have all the requirements, all the features, characteristics, everything. You're going to gather it from the end user. End user is going to help you with all these requirements. Now, as we know, this RAD application model, in here, you're going to divide this entire software into teams, and different teams are going to work. So in here, it is necessary that you make a plan. Planning is very important because multiple teams are working in parallel. So it is very necessary that you have a particular plan and each and every team sticks to the plan, so that in here when the time of integrating all the components come, all the components must be ready. Now, when the planning phase is completed, this planning phase, it is passed down to the modeling team. Now, in here, according to the number of components are there, that many teams are going to be assigned. This can be a team number 1, team number 2. Now, this can go on till team number n. The number of components that are there, that many teams are going to be there. Now, within this modeling phase, you've got 3 different types of modeling. You've got business modeling, data modeling, and process modeling. There are 3 different modeling techniques. I will just zoom in. Modeling, 3 modelings: business modeling, data modeling, and process modeling. Now in here, these 3 different modelings, the first one is business modeling. Now within this business modeling, what is going to happen is that this business modeling, you're basically going to make use of graphical representations. You're going to make use of graphical representations. Now these graphical representations, this particular diagram is called as DFD diagram. Now this DFD diagram is data flow diagram. Now this particular diagram, it is going to show you the flow of information. Now in here, in a particular application, you need to know how your data is going to flow from one component to another component. Now in here, we are taking an example, the diagram, we are taking an example of online food delivery systems. Suppose you're ordering food online. So the first thing is the customer. The customer is going to open this food delivery app, and then he is going to directly place an order on the food ordering system. Now in here, the customer is able to directly communicate with the food ordering system, and the food ordering system is also going to communicate with the customer. That is why the 2-sided arrows. Now this food ordering system, this is controlled by the manager. This manager is the one that has made this food ordering system, and in here, this manager is also going to directly communicate with the food ordering system, and the food ordering system is going to communicate with the manager. Now when the customer has placed the order on the food ordering system, this food ordering system is going to check the availability within the kitchen. The order that you're placing, whether it is available or not, that is going to be checked within the kitchen. Now in here, this manager is going to supply this particular food delivery by the supplier to the customer. So by this, you can know how the information is flowing from one part, from the customer to the food ordering system, then the kitchen. This is how the information is flowing. This is how business modeling works. The next type of modeling is data modeling. Now within this data modeling, all the information that was collected within the previous phase, that is your business modeling phase, this all information is going to be analyzed. Now this entire information is analyzed so that you form data objects. You're going to form different data objects. Now what are data objects? Data objects, the data object is going to tell you the behavior of the system, and it is also going to have attributes of the system. For this type of representation that is in here within the data modeling, you're going to make use of a ER diagram. ER diagram stands for entity relationship diagram. Now in here, you can see you have student, college. The student studies within the college, and in here, this student is going to have different attributes. The student ID, student name, student address, these are all your attributes. These three are attributes. Then the student is studying within the college. This particular college is also going to have attributes. These are the two attributes of the college. So in here, first you identify within the business modeling, you identify the flow of information. Then within data modeling, you take all that information and then you're going to model it into an entity relationship diagram so that you know what are the different attributes of each and every object that is available within the software that you're developing. Then the next phase is process modeling. Now within the process modeling, within this, what you're going to do is the software process that you're representing, all the information is collected and it is going to be given to the construction people, to the developers, it will be given. So in here, we'll zoom in into the construction phase. Now within this construction phase, we have got again three different components. The first one is component reuse, automatic code generation, and testing. Now this rapid access development, as the term is rapid, now how are we developing it in a rapid way is that now in here what you're going to do, the components that you're going to use, these components are going to be reused. That is, all the previous components that you have, you're going to make some changes, or if changes are not required, you can use the same component and embed it into the architecture. That is component reuse. Now this component reuse, this is the main thing that is going to help you within the rapid development of the software, the component reuse thing. Then the next thing is automatic code generation. Now within this automatic code generation, you can convert the data objects, like within the previous slide I have shown you the different data objects. Directly you can change a particular data object into line of code. You're going to have us automated tools for generating the code. The coding will be done automatically. Then the last part is testing. Now within this testing, what is going to happen? You are going to test all the features. Now in here, as you're using the component reuse is being done. So it is now as component reuse is done, what happens? All these components as they were previously designed, a lot of testing techniques are already done on it. You know how the particular software works. So in here, it is going to take less testing time, because multiple testings have already been done. Now this within this testing phase, what you're going to do after embedding a few features, a few changes that were required, you're going to add that and few testing will be done. In here, you can again save time as you're using the component reuse. Now after all of this is done, when the construction part is done, now in here, this modeling and construction, there's two phases. The two phases in here, that is the modeling and construction. This two phases, this is done for one component. Then within this team 2, this is the first phase, this is the second phase. This is again in parallel. Then again, you've got again one modeling phase and again a construction phase. These all are going to occur in parallel. Now as all of these components are going to take place in parallel fashion, that is at a single time, at the end when all of these components are completed, you're going to embed all of this within the architecture. That is, deployment is going to take place. Now within this deployment, what you're going to do, as I've told, you're going to have one particular software in here. As if suppose you're taking this 3 different teams that are working, you're going to embed all of this within the architecture. 1, 2, 3. These 3 are going to be integrated. This is integration. When this entire software is being integrated, that is, all the components are added within the software, you're going to deliver this software to the end user. This will be given to the end user. Now the customer, this end user, is going to use the software and is going to give feedback. That is how the software is working. Now this rapid access development model, it is going to generally take a lot of customer feedback because you're embedding different components into the software. This is the RAD model. The next one, coming on to the advantages and disadvantages of the RAD model. Now, the advantage is that, as the name says, rapid access development, it is going to reduce the development time. Less time is going to be taken for developing the entire software. How many days have we discussed? It is going to take like 60 to 90 days, or it can be developed within the less time. Then it is increasing reusability. Reusability, how are we going to achieve reusability? By component reuse. You can embed different components that were already created. You can use that same part within a new software with little or no modification. These are the two advantages. Now this RAD model, it has also got a few disadvantages. Now within these disadvantages, the first disadvantage is that only systems that can be modularized can be built using RAD. Now modularized means only the systems that can be broken down into different components can be broken into different components. If suppose you do not have a system that cannot be broken into different parts, then you cannot use the RAD model, because RAD focuses on developing different components at the same time. So only you have the system that can be broken down into different components, then only this RAD model will be applicable. The next disadvantage is that highly skilled developers and designers. Now in here, the developers and designers that are involved within this RAD development, they need to be highly skilled so that they can work in parallel. You need to know what particular features you need to embed and how you are going to design them within the short amount of time. That is why you require highly skilled people. The next disadvantage is that if performance is an issue. Now high performance, as you know, as we've discussed, that multiple teams are working within the software. Now if suppose that there's the first team that is working at a very high speed, they're working at a very high speed. The second team is moderate, and suppose the third team, it is just going on a very low speed. So in here, when there is this type of lag in here, there is no performance in here at this moderate and low, this is going to perform an issue within the rapid access development. So in here, all the teams, they need to focus on high performance. Then the last disadvantage is that when technical risks are high, RAD is not appropriate. Now, when technical risks are high, it means that if suppose you're using a particular new technology, when you're using a new technology, you might completely not know the technology, or you might not know when you're embedding a specific feature, how the software is going to react. So when you have a lot of technical risk, you are going to avoid the RAD model. And this particular RAD model, it is basically applicable for large projects. It is applicable for large projects. It is not applicable for small projects. This is the end of the incremental process model. Thank you.